Okay, in this video, I go over how to determine how much data you need to collect. And keep in mind, this is before we do the research. So we don't have any data, but we need to estimate how much data to collect to make it worthwhile to do our study. If we don't have the time or resources to collect the required amount of data, then you should consider other ways other than a research effort to help you to develop a solution. So this is good information to know. Very rarely do we have time to measure everything. So we are limited to doing samples. And we want to sample from the population from which we're making decisions against. We want it to be a random sample that doesn't have bias in it. And we want to grab the data from the data that we're interested in studying. Almost always we want a random sample. Almost always. The other way is a non-probability or convenience sample. When you sample by convenience, that's the equivalent of putting a survey on ESPN and asking them who do you think is going to win the World Series. Well, the only people that are going to answer that are the people that go to the ESPN website and probably the only one interested in baseball. Which it's convenience. It's people that would be interested in that. It's probably not a random sample. You'll probably get a response very different from year to year in that. But we certainly want the purpose of what we're talking about in this lecture is how do we determine how much data to collect. We're going to look at two different metrics, and there's many, but we're going to look at a formula to calculate a sample size when we're interested in studying the population mean, and how much data to collect when we're interested in the population proportion. Two different formulas, different but related. This is the formula that we need. So we need to know what Z, sigma, and B are. We calculate Z based on the confidence level. So one of the inputs is how confident do you want to be? The more confident that you want to be, the larger the sample size. A second one is B. B is your precision. B is what we're how tight do we want to be when we come up with something. I want to have enough data so that I'm plus or minus so amount in the units of measure. So if we're estimating dollars and we're trying to figure out how much data to collect to estimate dollars, then our precision is I want to be able to know within plus or minus $1 or $3 or whatever that number is. The tighter that precision, the more data you collect. And then the standard deviation measured by sigma is just how much variability is in the data. If you have a lot of variability in the data, you need more data, a larger sample size. So how do we calculate Z's? Well, Z's are a function of your confidence. If I want to be 95% confident, then my Z score is 1.96. And this is where it comes from. It's from a standard normal curve. If you're plus or minus 1 sigma, you get 68%. Plus or minus 2 sigmas, or plus or minus 1.96, you get 95%. Here's an example. Let's say that we're trying to estimate how many meals are going to be eaten by a particular, at a dining club. You're going to join a dining club, think of a restaurant, and how many meals per month will they eat at that restaurant? And so we need to know that's what we're trying to estimate, is how many meals are going to be eaten per club member. We don't know. Well, to do that, we want to be 95% confident, and we want to be within plus or minus 1 meal. The last part of this is how much variability is. We have to have an estimate of our standard deviation, but if we don't have any data, it's hard to measure that. I mean, if we do have some previous research, we just get it from there. Or we can do a real small pilot test, which is a really small sample size, and ballpark it from there. But probably the fastest way, the most convenient way to estimate your standard deviation is to estimate two numbers, the biggest number and the smallest number, subtract the biggest, the smallest from the biggest to calculate the range, take the range, divide by 6, and that can be an estimate of your standard deviation. So if we're trying to estimate meals per month, we can say, well, the most they would eat would be 10, The fewest would be 0. If I take the difference of that as 10 divided by 6, my standard deviation estimate is 1.6. And that's what we plug in, and it calculates. Then we need to go ask 11 people how many meals per month they would eat. What about proportions? We got the estimated precision, and remember, a proportion is think of it as a percentage. The percentage of people who's going to vote Republican for the president, for example. We got 3 things we have to estimate. Our z-score, which is a function of our confidence, our precision is based on B, and our proportion. And this is weird. Remember, we're trying to determine how much data to collect to determine our proportion, but to do that, we need to have an estimate of the proportion. Well, the best way to do that is use the worst case scenario, and that's assume your proportion is 0.5. If you do that, N is going to be at its biggest. So we want to know the percentage of people that are going to join our club that we're going to ask. And we want to be 95% sure, and we want the precision to be plus or minus 10%. If you estimate your proportion right now without knowing anything at 50-50, and this is how the formula works, you put in your z-score based on a 95% confidence. Your precision is plus or minus 10% or plus or minus 0.1. Estimate your population proportion without knowing anything is just to make it 0.5, and it tells you need to go ask 97 people. We'll discuss a completely different way to determine a sample size based on effect size. We'll do that in another video. But let me show you a calculator I've made available to you. This is a calculator I've already set up for you. For estimating the sample average and for estimating the population average and the population proportion. So based on the example we just did, if I want a 95% confidence, you put in your 95. It automatically calculates a Z. If I want it to be 90% confidence, it'll change. You also have to put in the precision, plus or minus something that you want. How precise do you want to be? And then an estimate of your max and min, which will ballpark your standard deviation. The formula to calculate that's the formula out of the book. And I went ahead and rounded it so that it would be a whole number. For the proportion, the same thing. You have to estimate a confidence, a precision, and then you can also put in what you think the proportion estimate is right now. Notice what happens. That's the worst case scenario. If you know the proportion, the likelihood that people are going to join your dining club is only 20%. That's what you think it's going to be. If you put 0.2, look how much less the sample size drops to. You only have to have 60 people. So if you have no clue, make it 0.5, and that will give you this. This will be the absolute maximum number that you'll need. Okay, that's enough information for sample size. Thanks.